All right, doing another live room. I figure I'd do an overview of the unification part, the story so far. Yeah, the story. That's a better story than the what I'd call, um, the disconnected bunch of fables that physics is. And Einstein really did need his unification to make any sense out of most of what he said, because without it, yeah, you're just basically disconnecting gravity from the other forces, and you really need to make a bent space work all the way down, or it's all the way wrong. I think logically. So I think that was his disappointment, is that he kind of knew he was probably full of shit, but he knew nobody would, he could say, hey, I was probably wrong because, yeah, you can't unify this. And who knows? It'd be interesting to have a conversation with Einstein and be able to probe those kind of questions that he might have had. I mean, he did lament, that he hadn't figured out after a whole career in physics, he still didn't know what a photon was. you know, Stuff like that were sort of an indication that he wasn't too keen on the story generated by his contributions. I don't think he liked where physics was going, and I don't think he thought it was right. And so that's all I'm saying. So it'd be interesting just to see. Um, yeah, I would have liked the opportunity. Let me just say, I'd like the opportunity to spend 2 hours with Einstein, see if I could convince him that I got a better diagram of the game, um, and such. So I thought I would go. It really wasn't any reasonable comments to comment on. The asshole from the other day had left some comment about what physicists have I convinced of this, and like that somehow is when it's proven to be right, is if somebody agrees with me. I don't know. Is that how you prove something? Is who agrees? I don't think that's how you prove anything. Um, I think you have to have a reasoned argument, and it has to be persuasive in some sort of meaningful way. And I'd rather people understand what I'm saying rather than wait for some authority to tell them Gary's right. If you can't understand what I'm saying, and you can't understand the distinctions I'm making between what I'm saying and what they're saying, then yeah, you probably don't have a horse in this race, because you don't. Yeah, you can't judge because you don't have the competence to, or whatever. But yeah, I don't know what to say. Um, you can either appreciate um, the yeah, you can either understand the argument, or there's just no point in listening to it in a way. Uh, and I think I'm trying to make them understandable in terms of pointing out what they're saying versus what a reasonable person could say. Because I really don't think they're being reasonable. I mean, what they have spiraled off of the two slit experiment in terms of the whole multiverse bullshit and all this, it's just made up. It's just made up. No evidence for it at all. Nothing makes that make sense. But anyway, nothing. Absolutely nothing makes that make sense. And it doesn't solve any real problem. It just creates new ones. It doesn't make it make sense. It doesn't make it work better. It doesn't do anything. Um, yeah, it really doesn't. Oh, I have to check my volume here. Sorry, I forgot to turn the sound back on.
Do anything.
So my bad. Oh well, it didn't come through because I didn't have it on. So yeah, no, not my bad after all. It's okay. No crisis. All right. Hopefully, I won't get kicked out of the room again. Um, all right. So I don't know if I have to draw pictures. I'll try to do pictures in words. If I have to resort to drawing something, I'll draw it, but I really don't want to. I don't have to. So the thing I'm you know, oh, so the other thing I want to mention, yeah, the Ken guy, I got no response from him. So, bark, 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 bark. So all you Ken defenders, I'm just saying, look, I sent the guy a polite message requesting the opportunity to do the Skype thing, and he made the big bold statement he's willing to argue with anybody about that, and he knows everything. So I'm just saying, what else can I do? I took him up on his offer, and it's apparently not a real offer. Yeah, I think that's bullshit. Yeah, I mean, we really don't have to respect each other or like each other to have a conversation about physics. I really don't. I don't think. And yeah, I mean, if he's going to say things like, yes, you're an imbecile if you're a materialist, then yes, I'll say you're a jerk if you're a Teslaite. I mean, you're a fucking anal wart for brains. Tesla was a kook. A quite unmiraculous kook. I mean, he really didn't make very many contributions, for all your crap that he made civilization. He didn't do that. Not even close. All right, anyway. So, to begin, so in hindsight, you see certain things and you say, okay, now I see what physics should have done. Is they should have been more methodical in this approach to describing reality. And so I didn't do this. I mean, I got into this because the two-slit explanation was preposterous. That's the whole reason why I got into this. And I wasn't looking for a unification theory. I was just looking for a answer to why photons are diffracted. And so I fell on all this, in an indirect way. But, once you fell on it, you can sort of see where physics made its mistakes in the sense of even speculating about ethers is kind of unintuitive. And it goes back to the point I've made before about the idea of choosing, how there's choices. And I could say to you, okay, there's going to be a choice. The universe is going to be basically a push universe or it's going to be a pull universe. And logically, the arguments are all on the side of push. If you were to say what's simpler, what is more likely a dynamic to arrive out of a ignorant or stupid mechanism, the mechanism of a push or the mechanism of a pull. And, push just wins overwhelmingly because pull is always going to be more complicated. There's just no pull, again, requires some kind of bonding mechanism. You certainly can't pull something from a distance with any kind of sense. But obviously I can push things great distances by just giving them velocity. I don't have to do anything more than that. It's very easy to convey the velocity to them, where to pull them, somehow I have to transport the velocity to them first, and then they can move to me. So it's a two-step process where the push is a one-step process, I guess I would argue, at minimum. And then the idea of the two-step process requires somehow I have to locate something to be able to send it the come to me package. First I have to know where they are for me to reach out and grab them. So where pushing things, well, that's easy. I can just bang into it and I can push it. I can be blind and push things. I don't need to see to be able to push. And you kind of need to see to be able to pull. All right, anyway. So that kind of reasoning is, kind of what physics just decided not to do. And then they decide to talk about an ether for a while. And you'd think these smart people would say, well, wait a minute, isn't that creating an infrastructure that might be more complicated than the forces being conveyed by it? And doesn't that sort of not make intuitive sense? That the forces wouldn't be less sophisticated than the mechanism they're riding on. I mean, the train is more complicated than the tracks kind of argument. And we don't see that. We see that the forces are really simple, that photons do appear to go in straight lines from point A to point B, and that all the other forces are incredibly simple in the sense of you can describe their function quite simply. And anything complicated they do has to do with their interactions with matter, not their basic transmission. That seems very simple. So again, you have a intuitive or sensible or reasonable argument saying, ether, railroad tracks um, seems more complicated than it would need to be because what's moving on the tracks isn't complicated. It really is rocks falling down a cliff. There's just no reason to have a complex cliff. The dynamic doesn't need to be complicated. And these ethers need to be very complicated for you not to fall into all kinds of traps of them not catching more spiders than than there are, or how to describe that. I mean, they have to have a complexity, almost like a spider's web, where they don't catch your own feet, where the spider doesn't get trapped in his own web. So it becomes kind of complicated to create an ether that you can move through without there being friction and without this. And so all those conditions that this ether must function in make it a much more complicated thing. And it has more moving parts than the forces moving on it. So it's almost the reductionist argument of the sand argument again in footprints. The footprint is a simple function. And it's the granularity of the sand, though, that makes it possible. So you're almost saying that you need more complexity in the ether to be able to transmit the things that are supposed to be more complicated but aren't. So it doesn't make any sense to have 7,000 dominoes to make a domino flip over. And that's kind of the argument I'm getting to. Stupid cat. Sorry. I figured there'd be an interruption eventually. I should have thought of that before I started the broadcast. My mistake. So 1 minute interruption. It's hot in here, dummy. You're not going to like it in here. It's hot. Hot, 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 hot. All right, almost back. Yeah, he probably won't want to stay in, so I'll probably get interrupted again. Anyway, so there's if you were to start all the way over, go all the way back to, the first contemplations of the universe, and then but you had experimental evidence, you had all this more information, and then you said, okay, let's drip the facts into a foundation and say, okay, where's the starting points? So even when Ken complains about atomism, well, obviously atoms were kind of a misnomer because we name them atoms, but they're not really the atom. So they're atom further down. They're not the atom mechanism. And what that would be, whether that's a quark or some other thing, I don't think is terribly relevant. I think the idea of the quanta is what we do know, is that the photon does represent what could be qualified as the one, the simplest, most mundane elemental thing, a photon. And the unfortunate part is I can say the word photon and people just don't really, people have all kinds of perceptions of what that would mean. I would argue that what it means is there's a quanta, a bit, and there's another bit separated by a distance. So in a sense, a photon has to be at least two for you to see it. You can't have a frequency or a wavelength if you don't have two of them. And that they're identifiable as they go through the rest of the stuff. Okay, so I might as well get to the rest of the stuff. I might as well start at the beginning. But the point is that the atom, the fundamental element, isn't the atom. It isn't the electron. It isn't the proton. It isn't the neutron. It's something simpler than that, and as the source of the brick, and then you make the buildings. All right. So, all right. So the way I would, so my argument is going to be a simple argument. Everything is made of quanta, little bits, moving the speed of light. Matter and all the forces. Gravity, magnetism. Well, it's really gravity, magnetism. I mean, electricity isn't really a force. Electricity is a consequence of the magnetic thing happening, and the acceleration of electrons. And you accelerate electrons by throwing these bits at them, and the bits can be produced through different mechanisms. But technically, there's no electric force. There's the magnetic force and gravity. And those are forces. That's all there are. And then light is just one of those things with a frequency. So in a sense, a photon of light would be a stream of not electromagnetic, but a stream of gravitational magnetic field energy that has a frequency. It's polarized and has a frequency. So the only thing that makes the distinction is everything is so everything is made out of these little bits moving the speed of light. So right now, everything that you're made of, the fish that make the school that you are, okay, so that the fish that make the electrons, that make the protons, that make the atoms, that make all the forces that hold them together, the fish, okay, are the quanta moving the speed of light. And they're inside of you right now moving the speed of light. And that's the only thing that really exists is the fish. And the rest of it is just schools, packets, collections of fish. So what we recognize as something other than fish, that the fish we can't see because the fish are so, can't bang a fish into a fish. So it's the photon problem. We can't see the photons. We can see what they do. So we can see when fish go somewhere and do something because they impact it, they move it, they accelerate it. So we can see fish, obviously we're here, so to speak. They'll leave their footprint by accelerating an electron or accelerating a proton, by moving things that are big, schools, clumps of fish. But that's what you are. You're a clump of quanta. So there's only one thing really moving, and that's the little bricks. The little bricks are doing all the moving, and any illusion you have of you doing movement, you're only moving because your fish move. You're only moving because the little bits move, not because the big bit moved. The fish have to move for the school to move. The quanta has to move for you to move. All right. So that's sort of an interesting, I don't think it's an extraordinary claim, but if you were to say there's some extraordinary claim, that's the first extraordinary claim you could argue, is that I'm basically saying that matter is literally E equals mc squared, that matter is the energy still in the form of moving bits, And the moving bits are what give you shape, in the sense that I've said this before, but yeah, the photon is interesting in the sense it only has mass in one direction, the direction it's going in. It doesn't have any identity in any other direction. It only has mass in one direction. And you're made of stuff going in all directions. So obviously you have mass in all directions, in all three dimensions, where the individual quanta, each one only has mass in the dimension it's moving in. So the bricks are one-dimensional, and they're being used to build in 3 dimensions. So that's the interesting part. But I think it's quite logical when you think about it. That it's almost like the icon for this channel now is this idea of 3 rings. But the idea would be, I think, even tighter to the truth, is that there's an electron, for example, is made of 3 rings. That's 3-dimensional rings. And they're all perpendicular to each other. And one of them's small, and one of them's bigger, and one of them's biggest. And that would represent red, yellow, and blue light. But that's a whole, I don't need to say that to do this, the rest of this. I'm just saying that might be an added bonus, is that this theory might also explain light, as in the colors of light, and how they're produced by electrons, how an electron can produce any one of the colors, or any color of light, depending on its disposition, depending on how many fish are in what shell. And they're not really shells. They are flat, polarized hoops. So, as the icon indicates, they have there's lots of empty space inside of an electron, I think. It's my current theory. Could change if necessary. But it seems that that is a real giveaway to why electrons do accelerate in one direction and perpendicular, always perpendicular, release force perpendicular to their acceleration. That would explain that. Is that it has the other wheels are turning in those dimensions. And if it gains velocity or fish in one wheel, it loses them in the other wheels. The wheels switch places, so to speak. So the small wheel goes big, and then the big wheel has to go small, one of the big wheels. So one dimension gives away something when one dimension gains something. Yeah, I think that's interesting. Very, very interesting. Anyway, okay. So, all right, so let's do gravity. So I'm just saying it's all one thing. It's all this quanta, and you can, just by creating these 2 elements, polarization, an idea of a difference. So we could just use, for the sake of this description, let's just use color as a way of describing polarization. So I'm just going to say a mixture of color, and then I'll just explain that just 2 colors out of the mixtures of little colored dots are the ones being transferred. But we're really talking about polarization, and so in 3 dimensions that gets a little complicated, but I'm saying that's all it might be about, is just the fact that it's in 3 dimensions. And but I think color will work as an analogy. I'm not saying it's color. I'm just saying it's a way of understanding polarization, visualizing it, because you really can't see the difference between this and this in a 3-dimensional field of zillions of these things. You lose it in terms of having any meaning, being able to see it. But that's all there really is. So when it's polarized, the quanta, when they all come at the same polarization, well, that's not even a good way to say it. When they come at specific, the magnetism is created by the fact that the two poles of the magnet are polarizing filters. And what they're doing is they're converting gravity, the field energy that's all around us all the time, into a polarized force. So they're polarizing the entire field energy. See, I'm ahead of my argument. I don't want to get ahead of it. I'm just saying that the only thing that makes it light is just polarization and frequency, and magnetism is just polarization. So you really only have quanta, a zillion little BBs, all exactly alike, moving the speed of light in all different directions. And the only thing that changes anything in their interactions that are all kinetic is polarization. So all the interactions are purely kinetic, except certain perpendicular interactions, polarization is exchanged. That is, polarization comes in this way and leaves that way, and vice versa. So that's the only thing that's happening in the universe, is that there's a few interactions where polarization changes direction. And that's the entire thing, essentially, that makes the evolution of the field energy possible, the changing of the field dynamics, the color. All right, so let's just start with a field of a million, zillion, zillion, zillion times zillion, zillion squared, zillion cubed, whatever. Too many for you to even contemplate in any kind of realistic way, of these little tiny bits. And they're moving in random directions, so all directions. Oh. Light-headed. Yeah, I don't know what that is, but I'm having a little trouble with that lately. All right, so they're moving in all directions. And somewhere in the history of the universe, this matter thing happened. So I like to say that the field energy just naturally creates matter. I don't know if that's possible. But the key element is that what makes matter different from this field energy. So I'm just saying, so just the simple truth is we have this random field of these tiny bits moving the speed of light, kinetically banging into each other, which essentially means they just go straight through each other. You can't really see a kinetic interaction. It's sort of invisible. And that's all that's happening, though. So they're just banging into each other and essentially going through each other. And you really don't notice anything happening. It's like empty space. It's full of these little things doing this, and that's called gravity, but you don't see it until the planet moves. So it's always there, this pressure, this stuff. And you can sort of get the idea of that. I've explained it before, but if think of your computer screen as being this random field, and you just put your finger in one spot, you could sort of understand that in the random field, there would be a bunch of stuff heading right for you. And it would look like the opposite of a light bulb, in the sense that it's all just heading right for you. The path will inevitably get to your finger because it's going on a straight line. So it's a perfect pressure in a spherical manner, just like an opposite of a light bulb. You're being pushed, the force is pushing in on you, exactly like a light bulb radiates out. The pressure is radiating into you from the field of the random field. That's the inevitable consequence of this random field, is that at any location in the field, you are going to be bombarded with things pushing into you. So now you can sort of understand why things get compacted, but let's explain gravity further. So there's this constant pressure. And so we take this something called matter, and we can kind of understand. I've made the shadowing argument, but you can just make the obvious argument. If I put two things in the field, they will, if I could actually make a field of little ball bearings, and then I put two discs in the field of moving ball bearings, the discs will be pushed into each other by the ball bearings, inevitably, because of this shadowing dynamic, because the straight line force can't go around the corners. It can't create pressure in between the two items, so there will always be less pressure between them, and they will move towards each other. And the closer they get, the more shadow they create, and the more the external pressure will be greater than the internal pressure, and the faster they'll be pushed into each other. So that's intuitive, sensible, but the real mechanism of that force isn't pushing. The ball bearings aren't pushing and bouncing off. What's really happening is the matter is a polarizer. So let's understand the electron. We'll just use electrons and protons for the sake of argument. And I think the neutron's role is just to keep electrons from falling into protons, but let's not get into that right now. But you just have these two bodies, and let's understand that protons, so understand that the field is all these different colors. So it's red, green, blue, pink, purple, all kinds of different polarizations. So 100 different colors. And that's called the field energy, the total universal quanta energy. And when a thing is sitting in that field energy and it's matter, what happens is that things of a certain, from each direction, a different color will be filtered out. So you can sort of, it's back to the three-dimensional wheels turning kind of thing. But for the sake of this argument, let's just use one color. So there's two items in this field. And what's happening is that this item is going to accelerate towards this item. But it's not going to accelerate because it got pushed. It's going to accelerate first by randomness alone. So that if I just place two items in there, neither one's accelerating towards the other. But what they are doing is jiggling back and forth and up and down. They're jiggling in all directions. So you can sort of understand, if all this field energy is there, there's going to be times when it gets hit by 3 from this direction and only 1 from that direction. So it moves a little this way. And then it gets 10 from this direction and only 8 from this direction. So it's always vibrating. Anything stuck in this field is going to be vibrating based on the randomness of the field energy. It's never at perfect equilibrium. It's always at consequential. Eventually it's equilibrium over time, but in any one moment of time, it's not equilibrium. There'll be more came this way than came that way. In the last hour, it got hit by 1,000,000 from this direction and only 999,000 from this direction, that kind of thing. So it's moving, it's jiggling. And what it does is that I put these two things here. What happens is this one jiggles a little towards this one. Now what happened when it jiggled, what really took place was the energy, the quanta, came in, say red, and what it's going to get converted, the red is going to get kept in here, and it's going to expel blue. Okay, so it's taking a new fish. So the matter is only blue and red. So it's only protons and electrons. So the protons, they eat red and they expel blue. The electrons eat blue and expel red. So if you go back to fish, electrons eat the blue fish, keep blue fish, and eject red fish, and the proton does the opposite. It keeps the red fish and it lets blue fish go. And that's its identity. So that's how you accelerate it. So, and the red and the blue represent polarization. And so it only keeps a certain kind of polarization and it ejects the other polarizations. It ignores them. It doesn't care. Okay, just doesn't pay any attention. So it only cares about the red fish or the blue fish. So the electrons only care about blue, the protons only care about red, or vice versa. Doesn't really matter. And that's the nature of the plus and the minus of the magnet. But anyway, this isn't magnetism. This is just gravity, and it's only polarizing, turning. The proton is only turning red to blue, and the electron's only turning blue to red, and it's expelling the other one, in the sense that it absorbs. So it absorbs the red. So the two things are sitting here. And what this one, when it jiggled a little towards this other guy, what it did was it absorbed blue and red. So the protons took some blue, they released the red sideways. The electrons took some red this way, red fish going this way, and they let blue fish go the other way. So what's happened is now the energy hitting the other body is absent blue and red fish. It has still all the other colors, but it's absent those two reds and blues. And what is going forward, okay, it still released another fish forward. Sorry, I should have said that. There's always, the stuff is always going through. There's no such thing as something stopping in here. It doesn't stop, it just exchanges. So if you could think of it as think of the matter as it's still pieces, they're flying in and out of it all the time, but just think of them as static pieces that you have to, if you hit one in, you hit one out. And then when it accelerates is when you have this little extra circumstance where it switches the polarization. So the polarization goes out perpendicular, but the extra fish actually goes out the front. It's not like one came in and nothing came out the other end. Something came out the other end. It's just that it's red, green, blue, pink, purple. It's not a polarization that's relevant to protons and neutrons. All right, so the point is that what happens in gravity is that the one body starts absorbing. So it absorbs some blue and red in the sense that it exchanges fish it has, green fish, yellow fish, whatever, for blue and red. So it takes blue and red out of the field and it lets go yellow or pink. Now, the matter over here doesn't see yellow and pink. It only sees blue and red, right? It either sees what the proton absorbs or what the electron absorbs. So it doesn't care about the other colors. So it's obviously this side of the field, as far as it's concerned, has now got less fish. I mean, let's just say from the proton and the electron's perspective, none of the other fish exist. They just go right straight through. They're essentially invisible. And all they care about are blue or red fish. And I've just lessened the number of blue and red fish. Now there's the same number of fish, but there's less blue and red ones. And there's more blue and reds on the other side of it, right? So now it's getting more blue and red fish from one side and less blue and red from this side. And that means it's going to move in the direction of where it has more fish that it's going to end up absorbing. So it's going to absorb the fish, the blue and red from this side, which means it's going to accelerate towards this other guy because it won't have anything to compensate for that acceleration. So now this one accelerated a little bit randomly. Now this one's going to respond, okay, with a non-random jolt. This one's going to see that jolt and say, hey, it's coming right for me. He ate my fish again. So this one's going to jolt some more. So basically the gravity is induced through this feedback mechanism where they just start eating the blue and red fish. They start absorbing all the blue and red fish, and now there's none between them. They're eating all the ones that are coming through them, and less of them are in front of them, and the space between them becomes lower and lower blue and red fish pressure. So I think you can understand what I'm saying. I'll hope. And what I'll just throw in real quick is that if you think about what I just said, and now you consider that what a magnet is doing, it's turning all the other colors, the pink, the green, all the other colors, it's changing to blue or red. So that's why it's so much more powerful as a force than gravity, is because it converts all the fish into blue or red fish. So everything that goes through it gets converted into blue or red. So a magnet is a polarizing filter. Okay, it's still made of electrons and protons are doing it, but because of the arrangement of the electrons and protons, whatever the arrangement is exactly, that arrangement guarantees that all angles are covered and that all fish coming from any angle with any polarization are going to come out red or blue. And so it's turning all of gravity into blue or red force. So that's the difference between gravity and magnetism. It's exactly the same mechanism, the same field energy. It's just that gravity uses 2% of the available force, and magnetism uses 99% of the available force. And what you have to understand also is that, remember, the electron, okay, doesn't care about redfish, doesn't feel them, doesn't see them. It only sees blue fish. It only absorbs blue fish, and it ejects the red, and vice versa for the proton. So it has it completely produces the kind of thing it is sensitive to. So it produces all fish that if it were in the field, it would get pushed by them. That's why the two poles repel each other, the two like poles. And when you invert them, you create the attraction mechanism, because when you invert them, the electrons are getting bombarded by the fish they don't care about, and the protons getting bombarded by fish it doesn't care about. So the pressure between the two gets nullified entirely to zero, unlike in gravity. In gravity, there was still 98% of the pressure was still between the two objects, because 98% of the colors were still there. But now all the colors are gone, and it's just red and blue. And if the electrons are getting hit by all blue, they're going right through it. It's not seeing them, and it's still seeing all the pressure from the outside. So that it's gravity really that's pushing the two magnets together, because it's not polarized yet. So the field energy coming in isn't polarized. The field energy between them is, and it's maximized either completely sensitive or completely insensitive. And so that's why the force is so much stronger. All right. So what this does, as an understanding, is you understand that the field energy is Einstein's bent space. It's the thing creating the convergence. It's pushing things together through a mechanism of absorbing directionality, absorbing the polarization or a kind of fish going a kind of direction. And so theoretically, if I took matter, and it has 3 dimensions in terms of the pieces inside of it, the proton and the electron are both made of the same kind of mechanism. They have 3-dimensional rings. And so if it starts to accelerate in one direction, it means the other rings have to be getting smaller and smaller and smaller, less and less fish in them, weaker and weaker, more and more transparent. And eventually, there's no ring. There's just fish going one way. So, but you can see that there would be a transition from this complex object that would be called matter into straight line field energy. That you'd first have to destroy the 3 dimensions, and then you have to get rid of the spiral. And those stages of destruction, like we can't accelerate matter, so there's to anything near these speeds, so we can't see this. We can't see this destruction. We can do it, but we can't see it. That's the problem. You can't see it being turned into energy. So it's an academic conversation in a way. But there was consequences to that mechanism. And one of the consequences would be time dilation, in the sense that as you accelerate matter, it loses the perpendicular dimensions. So the faster it's going in one dimension, the slower it's going in the other two dimensions. And that means it's can't tell time anymore. Its metabolism slows down, and whatever functions it has slow down in terms of how many times a certain event happens. It's going to happen less often the faster it goes. So I've used this dancing analogies, but I'll just use it again. If you're dancing as fast as you can, and then I tell you that you now have to move to your right as you're dancing, clearly you can't dance as fast, because now you have to take some time out of dancing to do the stepping to your right. And so that's essentially time dilation. And matter's doing the same thing. It's moving as fast as it can all the time. All the time it's dancing as fast as it can. And if you force it to move in one direction, it's going to be dancing slower in the other directions, so to speak. All right. Yeah, I think we got that covered. So the catch to all this is that this clearly unifies all the forces as being just one force, and all that changes is the polarization. And like I said, with light, the only catch is that it's frequency at a polarization. So if I took a stream of light, a ray of light, not a beam, but just one single, say there's 6 photons in this stream of light, this little ray of light. There can be all kinds of other color quanta in there, but the light itself will be identified by specific locations where, let's say, there's red or blue or green or purple or pink, but whatever it is, a specific polarization. So it would be purple, and then an inch away there's purple, and then an inch away there's purple, and then an inch away there's purple. Now there can be all kinds of other colors in there, but what identifies the photon is the polarized elements and the distance between the polarized element, and that defines a beam of light. And when the light's going through the field energy, yeah, it's crashing into lots of stuff. It's all the little bits are exchanging, but you can never exchange the frequency. The frequency can't be exchanged. It can't be knocked out of it, because as something comes in and hits it, right, something still goes in this direction. And so the frequency is always going to be maintained, even if you change the polarization, but you can't change it anyway. But that's what light is. And it's recognized by an electron because of those distances. So it's the amount of energy, the quanta of energy at a specific timed interval arriving. Now, whether it has to arrive at 1 electron or not, open question. I mean, I've come to the conclusion that it really wouldn't matter if all the electrons are magnetically. Again, understand that matter isn't a solid thing, in the sense that the bits that make it up are constantly being changed. But what is constant is the identification of its polarization. So in a sense, it's locations with a polarization. And the location with the polarization only changes when you move the matter, in a sense. So when the matter moves, the location has to change, because the whole piece of matter is moving. And all the little bits inside of it has to move its location. But the idea of the orientation between this one and 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 this one stays the same. So it's like a bunch of magnets, if I took a bunch of little magnets like these, and I put them all north side up, and I arrange them, they'll all have a force. They'll keep them at a locked distance between each other. And essentially what's happening with a photon of light going into an electron or going into an atom is that that bit of energy comes in at a specific time. So one hit, the quanta comes in, it moves an electron, but it doesn't move it far enough for it to push the other electron out of its space. So then the other electron gets pushed out of its space. So the other electron gets pushed out of its space. But if another hit happens quickly enough, then it will push into the next location, and it pushes the other electron. So it either pushes the electron out of the orbit temporarily, perhaps, or not. And that has to do with whether the photon gets absorbed by the electron or whether it gets readmitted. It's going to get readmitted if the electron bounces back, even though it got pushed and it got locked again, and then the photon will be released, maybe out of the fifth electron, but it'll be released again in 2 packets of quanta, just like it was absorbed. But its direction will be different because it's going around a curve of an atom or something. So it's not necessarily going to maintain its integrity. But obviously in substances like glass or transparent substances, obviously it is maintained. So the force comes at a specific angle. It goes through all these magnetic loops of pushing electrons around, and then the last electron readmits the photon at exactly the same angle. And it seems, well, wow, that's pretty incredible, and go all the way through all those interactions. So that's how precise the universe is. The universe is exact. There's no accidents, no fudge, no a little bit slower than the speed of light. No, it's all quite perfect in terms of its function. Doesn't make mistakes. So even things miles apart have an exact distance by a very precise math. There's no offness ever. There's no losses. There's no, well, I already said, it just doesn't have much error code in it. So yeah, so all you have to understand about photons is that they're far less dense in the field energy than the field energy. Obviously, the field energy is huge, and the amount of field energy that's in the form of photons is tiny. So it has very little impact in a sense, because you're not really realizing that the amount of energy going through you is 1,000,000 times. Like you could have the lights on all bright, and the energy going through you right now is a nuclear bomb worth of energy, realistically. Right now, it's going right through you, though. See, but it's not polarized. It's only dangerous to you. Field energy is only dangerous to you when it's polarized. When it's of random polarization, it's just a kind of gravity, and it's not a threat. Okay, and it's not even gravity, right? Because gravity is only when you take the blue and the red out. You have to create a filter, a material filter, to take the blue and the red out. So in a sense, right now, right around you is the same amount of energy that if I blew up a nuclear bomb would be released. It's just that it's in a different form. It's in a benign form when it's random and what's the right word for the equality thing? I forgot the word. I said it earlier. Equilibrium. So we have perfect equilibrium. But what's happening in a nuclear bomb is you have completely opposite of equilibrium, in the sense that you have all this blue and red. And when you blow up the electrons and the protons, they're going to release a ton of just blue and red polarization. That's what they've been collecting, is strictly dimensional, one-dimensional polarization. So they've been collecting polarization, a bunch of stuff in 3 dimensions, perpendicular to each other. And it's the release of all that perpendicular, all that right-angled kind of energy that just annihilates your matter, because your matter reacts to it. The protons and the neutrons, the protons and the electrons that make you up are completely sensitive to the blue and red that all of a sudden is flying at you in tremendous amounts. So it's just about the collection of color in a way. That's what matter is. It's a collection of polarization, and those collections of polarization, which we call the proton and the neutron and the electron, the nuclear bits that become matter, those become polarizing filters. And in the case of magnetism, if you align them right, they become very, very powerful polarizing filters. In that they start to exploit the entire field. They start to exploit the real power of the field energy. Reveal it. They can't exploit it. They can only reveal it. Right? There's no real exploitation of it because it takes work to do the polarizing. So there's no necessarily free energy. I mean, the only free energy is in the sense that we know that the matter is doing this polarizing thing, and that some energy had to go in to make the matter, and that's what you're releasing. So yeah, as long as you can burn matter, you can create free energy, but that's the only place you get free energy, is you have to find a place to get free polarization, and that's what matter's storing polarization. Yeah, I think that's a good way to put it. All right, I'll take a little break, read some comments, I guess. So I think you get what I'm saying here is that all of this, if you start over, you can take this nice simple diagram of a simple mechanism with a very simple function. You don't need bent space anymore. You don't need to put time in a new dimension. You don't need multiverses. You don't need any of this junk. You don't need to invent virtual photons because you can have actual photons. And it's all one mechanical force. All the forces move at the speed of light, which fits this perfectly because that's exactly because they're saying this. Look, they're the same thing. Of course, they move the same speed. But the funny part is that they're the only thing that is. Force is the only thing that exists. Matter is just collected force, technically. Yeah. All right. Let's see. Fruit unsure, fickle towards physics. Vacuum energy. Is the gravity field toroidal shape? Don't do this. I'm not doing this toroid crap. Well, whatever. They don't exhibit any toroidal shape. That's all just bibble babble. Obviously what's happening inside of a magnet is that electrons are basically, there's a current. So what's happening is the quanta inside a magnet from both field sources is basically going around the outside and shooting in towards the center. So the center of the magnet, all the blue shit is going in one side and all the red shit is going in this way. So if you thought of it two currents, so yeah, in that sense, there's a lot of current inside of a magnet, in that the quanta, to create the polarizing filter, right, to create the perpendicular field energy, to polarize all the gravity, requires there to be a lot of electrons moving. And so, but they're not moving in some kind of like flying way. They're moving in the bumping way. So that's why that's why magnets are always ceramic or metal. That's why they're very hard substances, because those hard substances have a hard geometry to their atomic structure. And so what's really happening is the electrons are constantly they're constantly changing places. So so there's no smooth current. There's the electrons changing position. And it's that change in position that's always a little bit of an acceleration, and that's what's creating the filtering. So when I absorb something to accelerate, I release the opposite of what I absorb. So if I absorb blue to accelerate this way, I release the perpendicular dimensions of, well, obviously there would be two perpendicular dimensions, but I don't want to get into that. But yes, they'd be red or green, but they wouldn't be blue. Unblue. Yeah, but I don't want to get into that. But so yes, there's a lot of electrons moving inside of magnets, but they're not moving in the sense that the way they would move in a wire. They're moving in that they're just pushing their neighbor. And it's that kind of movement. All right. Vacuum energy and matter are the same thing, right? Well, you can't call them the same thing, right? The same, does that make sense? They're obviously not the same. They obviously have a form that makes them different. I'm saying they're made of the same bricks. That's what I'm saying. So force is arranged in terms of its identity, polarization. So it's segregated by polarization, and that's what gives force identity. So the identity of a force is based on its polarization, and matter segregates polarization. All right, energy is just a smaller version of matter. No, it's not smaller. Quantas are all the same. It's still moving the speed of light. It's just collected energy of a specific type. That's why I use color to represent type. So matter collects blue and red energy. It doesn't collect the other colors. I don't know how else to say it. That time dilation makes perfect sense. Yeah, that's true. Matter is energy condensed. Well, again, this condensed thing, it's not condensed. Really isn't. Jesus Christ Messiah. Nonsense. I am the light. You know, you're the retard is what you are. And you can certainly go fuck your God in the ass until you're both dead. Yeah. Yeah, or vice versa. I'm sure your God will fuck you. So what all gods do, they do fuck you in the end. Horribly. And then they molest you in hell, in heaven. Right? They molest you in hell. And then if you go to heaven, you probably end up being some virgin that gets fucked, you know, by some asshole, you know, who earned it by blowing somebody else up. It really is, the whole thing is quite insidious. I'm sure Jesus wants you calling yourself Jesus Christ the Messiah and making raggy YouTube comments. I'm sure that's exactly what Jesus would hope for you to do with your life, retard. It is quite funny. I mean, these people who claim a faith and then do something just totally embarrassing. You know, I mean, Jesus would find you an embarrassment. He wouldn't be proud of you, asshole. People. Dumb little fuckers. All right. So, yeah, I think I did a pretty good job of it. Only took an hour. It's not bad. So, yeah, I have to work on it, do diagrams and all that kind of stuff. But I just wanted to explain, because my original videos were a lot more, they had this idea of collecting the acceleration, and you're not really collecting anything, you're just exchanging. So you're exchanging a fish with the wrong polarization going the wrong way with a fish for the right polarization going the right way. And that's the matter. So your matter is made up, like right now inside of me, most of the quanta inside of me aren't me. Most of them are just flying through me. They're just passing by. They have nothing to do with me. Me is just the ones in the polarization shape, the right polarization configuration. So if you really looked at an atom, it's not surrounded by empty space. It's surrounded by a ton of shit flying through it, but that shit doesn't interact with it. It just does the kinetic thing. It bounces right through it. But that's kinetics. It looks like they should bounce off. Well, no, it's going to look like they went right through each other. And that's what all of that extra field crap is doing. It's not really interacting. If it interacts with my matter, my polarized bits, it does so in some kind of invisible way. It looks like it went right through, or it went, it didn't mean anything. This goes this way and this goes this way, or this goes this way and this goes this way. That's the same fucking thing. Yeah, it's that thing. So as long as my polarization isn't changed, all those interactions mean nothing. So the only thing that matters to my matter is the field energy inside of me that's the right polarization. All the other energy inside of me is just passing by. Doesn't mean anything. Well, it means something in the sense that obviously I'm going to be constantly changing my direction based on the gravity, the balance, the equilibrium surrounding me. So where Venus is, where the center of the galaxy is, all of these things are producing extra blue and red. And so every moment I'm moving in some direction. Now it looks like I'm just doing this thing around the earth and blah, blah, but I'm really moving in all of those. I'm constantly changing my orientation in terms of which way the polarization is actually going. But it's always the same polarization. I mean, which way it's oriented in these 360 degrees is constantly changing, but this part isn't. It's not doing this, it's doing this kind of a thing. I mean, again, I can't really draw a three-dimensional picture, so I can't really explain how complicated this gets when you three-dimensionalize it. But what's really happening is it's just changes on these three wheels of dimension. And what's happening constantly is this wheel gains a piece, this wheel loses a piece, this, that kind of shit is happening every micro Planck second thing. Yeah. Can't see the comments. YouTube is irritating. But anyway, my father will smite you. Well, that's really interesting. Jolly Roger. Well, I shall block you. Is that the same as us smiting you back? Well, I hope so. Gary, I've been watching you for over 10 years. Thank you for taking the time to discuss physics and philosophy all these years. Well, that's very nice. Thank you. I can't really help it, right? It's all determinism, and it just happened to turn out this way. just be, I mean, the irony is, if I would have lived my destiny as what I would have expected to be a person of some success and all that kind of shit. Yeah, I probably would have never gotten here, right? I would have never bothered to dispute the double slit experiment. I would have never thought about this stuff. I would have never. It's just kind of funny how the fate, does land you in a place, and just kind of funny how I got here. It's a weird road to the unification theory. Really weird. So anyway, the incoming particles that make you are constantly bombarded. Yes. Yeah, the irony is that when you're in the emptiest place in space, let's say, there's nothing around you. In a sense, you have your maximum velocity because you're moving in all these directions. You're getting jolted so much. You're getting jolted by the randomness of the field in some sort of maximum way. And it's almost a way of decelerating when you start gaining velocity in one dimension, because when you're gaining velocity, you're losing jitter in that direction. So you're not vibrating as much. And when you have a lack of equilibrium. So it's one little, I think, I can't be certain of that, but I'm just saying, I think that's true. That you start losing your Brownian motion as you gain acceleration and velocity, so that ultimately the quietest thing in the universe is actually the quanta going the speed of light. As funny as that sounds, it's doing the less. Uh, well, obviously it can't accelerate, so that's not a good example. But anyway, for matter anyway.
What's up, Gary?
I don't know. Who's this guy?
It's Joe Hill.
Oh, it's Joe. It's Joe. I didn't care for you much, Joe, so you better watch your mouth or you're not going to last long.
No, I'm just saying. I just came in to say what's up. I'm gonna log off this shit. So, what's
Oh,
up, Gary?
gee, thanks. That's just so special. You should at least bring cupcakes or something. I'm really not I'm not a social animal. I'm just letting you know that. So yeah, I'm never going to show up in your room and go, "Hey, Joe, how you doing?" That'll never happen.
I'll bring
Never.
Big Cruise or some shit. See you
Whatever.
later.
Okay. Whatever. I don't get it. But I don't get much. This planet is very confusing. I don't get the animals that live here. Yeah, just don't understand them at all. But somebody in the room, right? So that's progress. After 468 million years, I finally have somebody in the room that spoke more than 2 words. So that's something. But it is Joe, who can't remember what he called me the last time, but he wasn't very polite. So let's see if there's anything else I want to talk about. Yeah, so anyway, I just wanted to do this to correct this. Look, I got a lot of videos, and some of them I'm saying stuff that, yeah, just it's close to being right, but it's not right anymore because the new theory is a little better. I have fixed it a bit, and especially the gravity thing, relying on some element of polarization that fits right into the electron and the proton having to do the moving. I mean, they have to move for the planet to move. The little bits have to move first. The fish have to move before the school can move. That's the argument here. The fish do the moving, and the school thing just does whatever the fish are doing, if you get my drift. So the fish move, the bricks move, the building doesn't move, if you get it, what I'm saying. And that movement is initiated by really a kind of magnetic force in the proton and neutrons. And that you see that force, that's the strong force in nuclear physics, right? Um, but that force is really exploited in magnets when they start to polarize all of the field energy, not just the blue and the red. Oh, it just fits so well. Yeah, just really liking it. I've got it. I mean, I'm just so damn sure I've done it. The holy grail of physics, and I tripped right over it. Uh, you know, and I did it just because these assholes and their silly freaking photons can read your mind bullshit. I mean, if they weren't so ridiculous and these silly interpretations of the two slit experiment, I never would have done this. It's only because that crap was so fucking silly that somebody had to go find the right answer, because that can't be the answer. This silly nonsense. And then especially Huygens. I mean, Huygens is just so fucking nonsense. It's a principle, but we only use it with the single slit experiment. Yeah, oh, that's some principle you got there. You seem to have toned down the AN arguments. Well, I don't know what you mean by that. Since your bad neighbors moved away, I don't see how that's relevant at all. I don't know what you're talking about. I've quite obviously spent a lot more time on this physics stuff because it's complicated and it's time consuming. And clearly, I've established a pretty hard foundation for the anti-natalism stuff, right? I'm not even an anti-natalist. I'm a fucking goddamn ethicist. Old Fan made the movie The Ethicist. I put up the website, The Ethicist and ethilism.com, and it's pretty substantial as a thing. Um, so I haven't toned anything down. So fuck you. Yeah, really irritating. Still have the gravitational lensing problem. I don't have a problem. Doesn't matter to me. I'm just saying that Einstein was called right because of this stupid prediction, and it wasn't even a prediction. He just guessed, and he was wrong. But I'm going to argue that light doesn't have any dimensionality. You can't. You can only, if you were going to be able to move it in some way, you'd have to move it in the only dimension in which it exists, which is forward and backward. It doesn't exist left, right, up, down. It doesn't have any mass in those dimensions. You can't move a fucking photon with force. You can't do it. All you can do is absorb directional fish and release directional fish through matter. Matter is the only thing that can absorb a fish, take it in as one of its own, and release a fish going some other way. Well, I don't know what that means. Is that Schrodinger's cat? I mean, everybody's just got to be witty and jokey and silly and stupid. I mean, here physics has been wrong for 100 years. It's all been based on a silly, nonsensical, phantasmagorical fairy dust pile of shit about these magical photons and their magical powers. And you're just going to sit there and make stupid Schrodinger's cat arguments. So it's refracted light at great distances. I don't even know what that means. No, there's no lensing. I'm just saying they don't have any good images of gravitational lensing. If you look at the images, they're nonsensical. The lensing can't, diffraction, nothing could exist where they say it is. It's obviously some other defect in their pictures. Some of them, I think, obviously these are time-lapse pictures, right? Well, some of them you can kind of get the indication that something's probably moving in the field. You know, but they're terrible images, and so I'm just saying they can't be used as anything. But I'm really arguing about solar lensing. Okay, Einstein predicted that the sun can lens, and clearly, if the sun could lens, then the Hubble telescope should be showing us all kinds of pictures of of stars behind our sun that we can see because their light was bent by the sun. The Hubble telescope can do it every day. It can let us see things that aren't where they're supposed to be. And if they do it like with a video camera, we should actually see the star behind the sun. We should actually see it do exactly like the two slit. We should see it actually exist and then disappear from its forward position. It should just like disappear for a little while and then reappear again. If solar lensing were possible. But it's not. So whatever. I mean, you're the one who brought it up. Like I said, it doesn't have a whole lot to do with my theory beyond the fact that I would just contend that if light could be bent, then it couldn't get across the field energy of the universe, right? Because by my theory, all this gravity and shit is real. It's shooting through space all the time, and a photon wouldn't stand a chance of surviving if it had a perpendicular mass. If it had perpendicular mass, it'd be getting jolted all over the fucking place. I mean, I'm not using bent space for gravity. So if I'm using a real kinetic field energy for gravity, then it would have to be getting jolted all over the place. It couldn't, yeah, just couldn't survive. Photons wouldn't survive. The frequency would get broken eventually. So, look, a giveaway on some of these lens images from the cosmos too. Another giveaway is the light is so bright. So if you look at some of these lensing images, they're not little faint things. They're hugely bright things. And if you think about what the lens is doing, the lens isn't capturing the whole image. So it's not like a regular lens. It's just a line of gravity. It's not a full lens where the whole inside is working. So it's like me taking a lens and putting black paint over the entire middle of the lens. I mean, it would be just a tiny little bit of light that you're going to get from the image going through one tiny little bit. And so the lensed image should be really faint, not hugely bright. I mean, they're saying they're seeing the brightest galaxies in the universe through lensing, right? So they're seeing a galaxy behind a galaxy, and they're saying it's the brightest one in the entire universe because, yeah, the lensed image is so bright that they can't account for it any other way. They have to say it's the brightest galaxy in the universe because the light is so bright. And I'm just saying, isn't that sort of convenient? That the brightest galaxy in the universe just happens to be stuck behind a galaxy where we can't see it. Just coincidentally. Yeah. It's always like that, coincidences. The smallest thing in the universe that we can't take a picture of is doing all the sneakiest things in the universe. Just coincidental. So anyway, in this video, I have given you a Occam's razor simple description of reality. You don't need any bent space. You don't need any complex time relativity bullshit. There's one thing moving. It's a constant speed. The speed never changes. It never gets warped. It never gets bent. None of that shit happens. Time is one thing. Matter breaks. That's the point. Velocity breaks matter. You can't move matter anywhere close to the speed of light without breaking the fuck out of it because it's turning it back into force. If you take away its dimensionality, matter ain't matter no more. That's what makes matter matter, is the 3 dimensions. Yeah. Without the 3 dimensions, it ain't matter. Obviously, you can't be going the speed of light that way and still have pieces going this way and that way, right? Come on, you can understand this, really. So anyway, let's see if there's anything else happening. So I would like for the Ken guy to grow some fat balls debate me or anyone else, but you know, might as well debate the nuts. I mean, it's disappointing that there's these crazy fanatics out there, and they won't put themselves, you know, they won't open themselves up to these conversations. It's like the Miles Mathis guy. He just keeps it all on his little website. It's all out, no in, you know, no real interaction. You know, only on his terms. The stupid rope theory guy, he doesn't allow himself to be challenged by anybody. Doesn't even let you comment on his videos, which I sort of understand, just because the comments are always so stupid. But again, it's, I don't, no balls. So, I mean, I'm here. Anybody who wants to have a civil conversation, I'll have it. And I mean it. I'm not the one that's going to be insulting first. So you're going to have to, you're going to have to ask for it to get it. Oh, fuck. Not this digital universe again. I mean, in a sense, everything, yes, anything mechanical has to be, in a sense, digital. Even analog things are digital in a way. Broken down in Planck moments of time. It's all digital in a way. It's you know, the very concept of light going from point A to point B in a straight line is digital. So there's no, I mean, an analog would be an angel. An analog would be something not mechanical. Anything mechanical essentially has to be founded in digital mechanism. It can look analog from our dumb senses, but I'm just saying it's still a digital mechanism that created it. There still has to be a time cycle, a rigid mechanical process. So I just saying, calling it a digital universe, I think that's just dangerous. That's like the people with their electric universe. It's just dangerous rhetoric, and it's not even descriptive of anything. Um, it's a mechanical universe. Physics is physical. Yeah. Yeah, Bill Grady directed the comments to his associated Facebook group. Yeah, well, I'm just saying, I'm not going to have a Facebook account to leave a comment. But the point is, he doesn't read the comments. He doesn't respond to comments. He doesn't make videos answering comments. I'm just saying, he doesn't. He's all out. You can't have an interaction with him. I sent him a PM once, and all he did was preach at me. I wasn't like preaching at him. I'm saying, look, we agree on a few things. Why don't we talk about this and blah, 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 blah. And all he did was say, you're wrong. It's rope universe, blah, blah. And he just preached at me. I was like, no, I've already heard your videos, asshole. I don't I don't need to rehear your video, you shithead. I've watched your videos. You're the one who hasn't watched mine, you cunt. It was just pretty obnoxious when I think about it. And the Miles Mathis guy is just the same kind of cunt. I mean, he put a notice on his website, that I'm not him, and I've never implied I was him. Never did anything like that. I never, it's just such bullshit. And then he sat there and added a little raggy comment like, "Well, one of my commenters has informed me that if you go to his channel on YouTube, you'll get spammed with a bunch of his videos in the recommended section." Like somehow I did that. Yeah, that's not what I do. That's what YouTube does no matter what video you go to. So yeah, go watch a video of 10-year-olds wrestling and you'll probably get a lot of, boner videos and stuff. Yeah, that's the way YouTube works. It's not my fault, asshole. There's no ads on my videos, cunt. I mean, I just thought it was a little raggy comment. These people are just so fucking petty. Really petty and gutless. Yeah, petty and gutless. Yeah, and weak and smelly. Yeah. But the Ken guy is kind of pissing me off, and I don't want to go to the trouble of playing his video. But I mean, come on, he's just sitting there saying, I know more about field theory than anybody, and I'll debate anybody on Skype, and blah, 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 blah. And then later he says, I'll pay $10,000 for blah, blah. And he doesn't really say anything about who he's going to pay. But, I don't know what he's expecting, God to show up? I mean, I've made the same offer. Don't get me wrong. There's nothing wrong with offering money to get a real physicist to make an argument. But frankly, he should start off with something a little easier. I should be a really easy target. So how come he's afraid of me? Yeah, well, I've thought about painting the ceiling, but frankly, that's how I start off with the texture. Because I was going to do I was going to be a real Rembrandt. That's why I texturized it in the first place. Um, but I also said, why the fuck do I want to do that? Yeah, it's a stupid idea. So I said, fuck it. But again, why do people worry about this shit? I mean, why the fuck do you worry about my ceiling? Why should you care? I mean, if I videotape my floor, you should see my goddamn floor. You think the ceiling's bad? You should see the carpet. The carpet's been down for like 15 years. Uh, you know, fuck. Yeah, you should see the fucking carpeting. I mean, it's years of cigarette smoking and whatnot. Does that matter to you fuckers somehow? That I mean, this kind of shit really, do you give a shit about that, or are you just wasting people's time with that kind of nonsense? You can't. Your brain is just so fucking lost in the generic Coke Pepsi war that you just can't do anything better than say, "Oh, his ceiling isn't normal. Oh, that's not right, having an abnormal ceiling." Oh, I'm gonna call the abnormal ceiling police. I mean, it's just so fucking stupid. If I don't care, why the fuck do you care? I never look at my ceiling. I just never do. There's cobwebs over here. I never look and say, oh, look at the size of that fucking spider. No, I never bother doing that. Ever. I just couldn't give a shit. That's why I actually get something done. You see, that's why I'm actually productive and have found the unification theory is because I don't waste my time worrying about fucking peeling paint. And the other point is look, I don't have a regular landlord. You see, my landlord died. It's all been, and he was getting old anyway. So he doesn't pay to fix anything. So I have to do it. I don't, I'm a renter. I'm not paying for it. You get it? you know, that's why I don't care. Okay, the landlord didn't care. Well, I'm not gonna fucking goddamn care. I'm not fixing his house for free. Fuck that. Well, I mean, I keep what I do. But yeah, I'm saying it's like I need a new roof. And I've needed a new roof for like 8 years. Badly in need of a new roof, but I'm not paying for one. I mean, it was I don't really want to get into that personal shit, but I spent years, I had to do all the work around here. I had to fix the other cabins, and I forked out money for stoves and all kinds of stuff so they could keep renting the places. And yeah, yeah, I was very nice to my landlord, and then he died, and we could just no point in being nice to people who are going to die, right? Because then all the nice stuff is dead. Like, oh yeah, all those favors I did, well, they're just died with him. So now that was a waste of time. I mean, not that being nice isn't a nice thing to do just for the sake of being nice, but I just mean you got no chance of any reciprocal payback. When the guy you gave the nice candy to dies, you're just not going to get any candy back. Yeah. So, I'd say I sort of am a work of art, really, art in progress. Yeah, there's nothing. I mean, you can certainly, in hindsight, it all seems kind of, chain of events, blah, blah, blah. You can kind of see where you ended up. But when you're actually going there, you can't see how it's happening at all. I mean, it all seems so helter skelter. Yes, that's what it seems. Anyway, so not much happening. So I guess I will, get back to my work. and such. And yeah, I don't know what's on my agenda. I mean, I do have to do writing, and so I really don't want to. I keep putting it off, but I really have to do that. And that's part what this video was for, was just to get me back into thinking about how to write it and how to form it and how to argue it and all that crap. So I'm not displeased that it didn't, like I said, an hour. It took an hour. That wasn't bad for a first try. Yeah, well, obviously I've done it before, but I mean, first try with a new mechanism, new. It's not even a mechanism; it's just a new focus, polarization. All right. Well, I guess it's good night and such. Gotta get more people in these rooms somehow. Probably a person. Yeah, a person who knows something about physics. Yeah, that's what I have to do. Yes, it was a good movie, the F-list movie. Quite excellent. Will be appreciated eventually, I think. Really, it's quite a brilliant piece of work. So, anyway, it's a different subject, though. Yeah. Well, until next time. Oh, it's hot as hell in here. It's really not that hot. I'm just hot. Take my temperature. Sure, I don't have Lyme or something. Anyway, till next time and such.